Hello GCC Chem 130 students. I'm going to be talking to you about Chapter 12. This is our first video in Chapter 12 and I'm going to tell you about the mole. I'm going to explain to you about the mole by giving you an analogy. Let's talk about eggs. When you go buy an egg, do you buy one at a time all wrapped up in styrofoam or something? No. They come in 12s, right? That's called a dozen. So eggs come in dozens because it's convenient to buy 12 at a time. What else comes in a dozen? Donuts, cookies, beers, soda, Coke, Pepsi, Mountain Dew. You can buy 12 packs. Yeah, so all those things come in dozens just because it's convenient. You don't want to go to the grocery store and just buy one beer at a time or one Coke. You buy a box and there's usually 12 in that box. It's a 12 pack. Same thing with eggs, same thing with donuts. So it's convenient to package them in 12s. Now, if a foreign exchange student said to you, what does the word dozen mean? What would you say? You'd say 12. And the student may ask you, 12 what? Well, 12 anything, 12 items. I can have 12 pens. I can have 12 little Yodas. I can have 12 cans. I can have 12 phones. So really anything can come in a 12, a dozen. Let's talk about atoms now. We want a convenient way to package atoms. Is it going to be 12? No, it's not, because atoms are too small to count out 12 of them. So they're too little, I mean way too little. So the convenient package for atoms is going to be a huge number. I mean huge number, not 12. And the scientist named Avogadro, there's his picture. Avogadro came up with this number. And the number, the huge number, is 6.02 times 10 to the 23rd. So that's like 6 billion trillion. It's a big number. And it's called the mole. Just like 12 is called a dozen, 6.02 times 10 to the 23rd is called the mole. We can also call it Avogadro's number, NA, number of Avogadro. So Avogadro's number is a mole, and it's just a super big number for atoms. Now, if we had a mole of softballs, 6.02 times 10 to the 23rd softballs, it would be the same size as planet Earth. So we don't. We don't have a mole of people, cars, phones, pens, Yodas, cans. We don't really have a mole of anything other than atoms and molecules on Earth, because it would just be too much. Now, a mole of atoms actually will fit in your hand. It's a handful. Now, if it's a little atom like lithium, it's a little handful. If it's a big atom like uranium, it's a big handful, but it'll fit in your hand. So 6.02 times 10 to the 23rd atoms can fit in your hand. It's convenient and it's called a mole. Another thing that's totally awesome about the mole, let's get your periodic table out, is the mass of a mole of atoms is the mass in the periodic table. Now earlier we just told you like carbon is 12.01. We said atomic mass units. But now we're going to say carbon is 12.01 grams in a mole. Grams in a mole. We're going to say that aluminum is 26.98 grams in a mole. We're going to say that sodium is 22.99 grams in a mole. It's called the molar mass because it's the mass of a mole. And again, a mole is just a really big number, 6.02 times 10 to the 23rd atoms. Here's some photos of a mole of some various molecules or compounds. In the bottom, we have sodium chloride, salt. So it's 58.5 grams in a mole of salt. We have some iron 3 chloride. It's that rusty, chunky stuff. Again, it's in a petri dish. That would fit in your hand. Copper sulfate's pretty. It's that light blue color. In front of that, we have some potassium manganate. That's pretty as well, a navy color. Then we have some potassium iodide. That's another salt. And in front, we have some cobalt 3 nitrate. It's that pretty red color. All of those samples would fit in your hand. All of those samples contain 6.02 times 10 to the 23rd molecules of that substance. So a mole is 6.02 times 10 to the 23rd entities, items, things, whatever. But it doesn't really, you've never heard of a mole before because it's so big. Again, we don't have cans or baby Yodas in moles. It'd be too many. We'd be buried in them. So instead, the mole is used for things like atoms, ions, molecules, and formula units. Let me explain what a formula unit is. That's a unit of a repeating salt. Like salt is NaCl, table salt. That's NaCl, 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 and it just keeps repeating. One unit of that would be NaCl. Sometimes I use the word molecule for that, which is actually incorrect. It's a formula unit. It's a unit of salt, the NaCl unit that repeats in the salt. So again, we use moles when we're talking about atoms and molecules. We can also talk about ions and formula units. So again, we talked about in the periodic table, the number that's the mass in here from now on is grams per mole. It's called the molar mass because it's the mass of 1 mole. So look at your periodic table. How many grams are in 1 mole of oxygen? So find oxygen. And if we're talking about atoms, it's 16.00 grams in a mole. How many grams are in a mole of gold? Find gold. I hope you know it's AU. And it's 196.97 grams in 1 mole. What about zinc? How many grams are in a mole of zinc? So find zinc. And it's 65.38 grams in that mole. And again, a mole is just 6.02 times 10 to the 23rd atoms. So there are the molar masses of the elements in atoms for oxygen, gold, and zinc. More, I want you to find the molar mass for silver, potassium, and silicon. Hit pause. I hope you hit pause. So all you had to do was find silver, potassium, and silicon in your periodic table. Silver is 107.87 grams per mole. Potassium is 39.10 grams per mole. And silicon is 28.09 grams per mole. Again, that's molar mass, and the units are grams per mole, not just grams, but grams per mole. How do you think you get the molar mass of a compound now? If these are the molar masses of the atoms, how would you get the molar mass of sodium chloride? If you said just add up the atoms Na and Cl, you're correct. Let's give this a try. Yeah, you add up the atoms' masses for the compound. Let's try barium hydroxide. So first of all, we need to know what the formula of barium hydroxide is. So I want you to look at your periodic table, hit pause, and figure out what barium hydroxide is. All right, so I hope you figured out barium is in the second column, so it's a +2. Hydroxide is polyatomic, it's a -1. So we need 2 hydroxides for 1 barium. So the formula is Ba in parentheses OH, end parentheses, 2. Now let's add up the mass for every atom. That would be 1 barium, 2 oxygens, 2 hydrogens. I want you to stop and add those up. Hit pause. All right. So if you added up a barium, it's 133 grams per mole. 2 oxygens is 2 times 16.00 grams per mole. And 2 times 1.01 for hydrogen. And we get 171.35 grams per mole. Again, the unit is not grams. It's grams per mole. And we just added up the atoms for the molar mass. All right, I think that's enough for this video. We will come back and check with you a little later in the other Chapter 12 videos. Goodbye, GCC.